Welcome to our presentation and demo on the PRBS pseudo-random binary sequence generator. This chipset currently generates 15 sets of numbers or letters in hexadecimal form, which are displayed on a 7-segment display for each cycle. While these sequences appear random and serve as a solid proof of concepts for testing data, it's important to note that they aren't suitable for encryption, as the cycle sequences aren't long enough to ensure security. Despite some limitation, the Tiny Tapeout platform offers a fantastic opportunities for lower division college students or undergrad students doing senior projects. Enable them to design their own chipsets and tapeout. Now let's dive in and explore how this generator works. This is the actual breadboard and wire connection from the board to a 7-segment display. So for the power source, I connected to the 1.8 volts outputs from the board and connected to the COM port on the 7 segments. And the rest of the connections from the output, it's directly connected to the 7-segment display. For the decimal points over here, that's the clock cycle. So you can see it turning on and off. For this demo, I'm going to select the program, and the 7 segments should start counting when I'm click the UIN. So here's the demo. It's gonna start counting by itself. At this point, you don't have to touch anything. It's just gonna keep counting till you click off the UIN. So deselect this, and it's gonna return to 0. Now I'm going to show you how to configure your Tiny Tapeout board. So first thing, click Connect to Board, select the COM port 7, and connect. Now changing the index number to your own design. For example, this one, my design is 47, and I press select. Then I change the clock speed. Over here, I'm gonna choose 1 Hz, so set. Then I'm going to interact and select UIN. This box enables the programs to run on itself. So go back to config and set. Now you should be able to see the 7 segments start running. This is the Wokwi simulation for TT05 index 47. So I'm gonna start pressing the start buttons, and now you can see the 7 segments light up. Now if I press and hold the reset buttons, it's gonna start jumping numbers and alphabets in hexadecimal. And when I let go of the reset button, it's gonna stop and return to 0. This table is going to show all the configuration of the hexadecimal numbers that's displayed during each cycle.
Compared to binary, stochastic computing is a method of computing using probabilistic bit streams. So in other words, you can say it's probability represented by bit streams. So for example, you can represent 1/4 as the probability of each bit being 1 with the sequence 0001 or 0010. The order doesn't matter the way it does in binary. In general, a degree of randomization in the bit stream is needed for stochastic computing operations. This randomness can come from the pseudorandom numbers generated by the PRBS, though there are designs where the randomness isn't strictly necessary. As an example, let's say you had an input as 1000, and that's your set value or the probability that you're aiming for. The PRBS will generate all possible combinations of values for that number of bits. So half of the time, those values will be more than 1000, and so the comparator will only give a value of 1 half the time. So you've managed to generate a stochastic bit stream that has half probability of being 1 in each bit and enough randomness for stochastic computing operations.